students, faculty, grad students, undergrads, welcome all to our ECE Colloquium event this week. This is the fifth one of the semester, fourth or fifth. It's our great honor and pleasure to have our colleagues from the Department of Innovation Ventures. They are essentially our technology transfer. They're from our technology transfer office here at Rutgers. So as you know, they'll talk more about the great work they're doing there. But essentially, if you have an idea or an invention, whether it's hardware, software, or something you're doing in your lab, whether you're a student, whether you're undergrad, graduate, whether you're faculty, staff, postdoc, it doesn't matter. If you have something that is patentable, inventable, you think industry ultimately may want to take it on, or you may be interested in doing a startup yourself, these are the people that you want to reach out to and disclose your invention to, and they will be your best friends. They will do whatever they can to help you along the way to get your the brilliant work you're doing in the lab basement out into the hands of broader society who can really benefit for that. So I think they probably have, if you ask me, the most, one of the, if not the most, one of the most important jobs here on campus, and that is finding the best way that society can benefit from our inventions. If you read the flyer, we kind of tried to pose some questions that are often in people's mind and misconceptions. There is this notion that I think, unfortunately, it's a misconception a lot of people have, is that if we invent something here, we get nothing out of it, and Rutgers just takes it for themselves, and so it's better to not even keep them in the loop, and better to do things off campus if you can. And that's a misconception that I think I hope everyone learns today, that that's the wrong way to be thinking. They want to do what they can to help you out and make sure that it's beneficial for everybody. So we have Dr. Tatiana Litvin Vechnayek, who is the vice president of the Innovation Ventures Group. Also, Dan Benderly and Andrea Dick. And so I know we're here to listen to them, not me. So without further ado, I'll let them get started. So I wish if this were in person, we would all clap for you and thank and welcome. But you can just assume we're doing it behind our computers.
Sounds great. Thank you very much, Mehdi, for your kind words, for inviting us. Dan, thank you so much for organizing, connecting, getting us invited, and Andrea, thank you as well. So we're thrilled to be here, and I see the number in the audience is great. We've done a few of these at other departments, and the attendance has not been as good. So we're going to need to figure out with you how you did that and what you promised or bribed them with, because it's really important to get us out there. Previously we were eager to get on campus and meet people face to face. Now we're eager to meet people, virtually face to face. I think there's a lot of value connecting this way on a regular basis and educating faculty. So we're really happy to have the opportunity to talk to you. As you said, we are everybody's best friend. I don't know about having the most important job, but definitely, obviously, extremely important in that we're here to help you move the ideas that you generate to market to impact society. I also would like to think that we have one of the most interesting jobs because we get to hear about all the super exciting new cutting edge innovation that you all come up with. So my background is in actually life sciences. So I'm glad that I don't have to do any technical presentation today because probably half of it wouldn't make sense. But I have a PhD in pharmacology from Weill Cornell Medical School. I did a postdoc, and then I bounced around a couple of different tech transfer offices between New York City and New Jersey. I'm also a patent agent and have been in licensing and intellectual property for over 15 years, 11 of them between Rutgers and UMD&J. So we have a terrific team overall, and two of the team representatives are here to talk to you today about software copyright licensing. I will, and sort of the process in general, and some of the other aspects of the team that has to do with new ventures, startups, hopefully mention a couple of gap funds that we have available as well. So without further ado, Dan, if you don't mind advancing to the next slide, or whoever has control of the presentation. Great. So our mission at Innovation Ventures, and by the way, that's a new name for us. We were previously known as Office of Research Commercialization. We just wanted to sort of refocus, refine our mission, and share that with the world under a new name. So the new name is Innovation Ventures. And our mission is to partner with the Rutgers community to encourage deliberate innovation, protect and leverage Rutgers intellectual property, foster collaboration with industry, and enable entrepreneurship. Next slide. So there's, as you may or may not know, there's a lot of really exciting innovation that has come out of university research over the years. And these are just some of the examples, but we could go into a lot of details on some of them. You may or may not know, but the seatbelt, the first modern version of it was developed at Cornell University. Gatorade came out of University of Florida. CAT scan, ultrasound, flu shots, a great number of chemotherapy drugs came out of various universities, and lots of other examples. Next slide. So all of that and offices like ours came about as a result of the Bayh-Dole Act, which was Patent and Trademark Law Amendments Act, implemented by Congress in the 1980. So before the Bayh-Dole Act, whenever the federal government funded work in your laboratories, the federal government would own the inventions that would come out of that research, not the university and not the inventor, him or herself. And the federal government didn't do much of anything with those inventions. There were not a whole lot of them. There were no proper incentives for the inventors to keep inventing and disclosing. There was no mechanism to move these inventions into the marketplace. And so they just sat there, or a large bulk of them. So in the 1980, the Congress implemented this legislation, which was really revolutionary for the innovation in America. It established offices, it helped establish offices like ours, and put specific responsibilities on offices like ours with respect to commercializing innovation that comes out of federally funded research. It allowed universities and other nonprofits that receive the funding to retain rights to these inventions in exchange for certain obligations. And these obligations have to do with sort of a commitment, a real commitment to commercialize for the greater public good, so that there's benefit to the taxpayers that are essentially funding the research. And we have to do continuous reporting to the federal government on what we do with every invention, essentially, that they fund. Next slide. So as a result of that, all universities that have federal funding have an IP policy. Obviously, Rutgers is one of them. So we actually have two IP policies because we're still reworking the legacy UMD&J, legacy Rutgers policies, hopefully into one. But essentially, they state the same basic things. The university holds the rights to the intellectual property invented by faculty and staff. University pays for patenting costs and fees when a decision is made to protect the invention and to move it forward. And Dan will talk a little bit more about the process of how we do that. So that's a significant benefit, because those expenses can be, quite significant, from tens of thousands to hundreds of thousands. But most importantly, we do active marketing outreach to prospective industry partners, and we negotiate license agreements on behalf of faculty and staff to enable commercialization of the university's intellectual property. When there is licensing income, it is distributed first to inventor. So Mehdi mentioned that there's a misconception, which I'm shocked to hear every single time, that when faculty invents intellectual property, the university just takes it and sort of, portrays the central administration as some sort of a greedy machine. Significant portion of the licensing income goes to the inventor personally, and that is in line with the Bayh-Dole Act that I just mentioned. Another portion of, by the way, the significant portion to the inventor, it ranges between 25 and 35% under the university policy. Another portion of the licensing income goes to our group to cover our operational expenses. And another portion goes to the inventor school, chancellor department, with the goal of sort of putting the money back into research, ultimately. Next slide. So we've been asked several times to provide interpretation, explanation, clarification, specifically to intellectual property generated by students. So as you know, we have undergraduate students and we have graduate students. In some cases, graduate students are more similar to employees and staff than to undergraduate students. So this is the clarification that we have provided, and basically Rutgers encourages its students to be entrepreneurial, to seek out new and innovative solutions to existing challenges, and we will disclaim ownership of all student innovation intellectual property unless it's conceived or reduced to practice under a sponsored research agreement or other agreement with a third party, so an industry, or a foundation funding or anything like that, within the scope of faculty supervised graduate thesis or dissertation work, within the scope of students' employment, or with significant use of university resources. So we have found this to work well and to provide sort of a clear cut of what we believe sort of belongs in the scope of the university intellectual property and what doesn't. But regardless of this, we're always eager to work with students, advise on intellectual property, even when that intellectual property belongs to the students. So we want to be viewed as a resource and an advisor to students that want to come and talk to us. Next slide. So what is intellectual property? It's a property right in an intangible item, and it enables people to earn recognition or financial benefit from what they invent or create. It can be sold, licensed, stolen, infringed, and is subject to a number of laws, such as IP law, property, contract, tax, as well as antitrust law. The intellectual property can be protected by patents, copyrights, which protects expression or style only, trademarks, which protects the brand, and trade secrets, which protects proprietary business information. So at the university, the bulk of what we deal with has to do with patents, which protect inventions or content. We have a lot of copyrighted items that we commercialize, and we're looking to expand that because we believe there's a lot that can be commercialized, and Dan and Andrea will talk about that. We have some trademarks. We don't have a whole lot of trade secrets because we're not very good at keeping secrets. Next. So there are statutory requirements to obtaining a patent. So the way that one obtains a patent is that you have to apply, submit an application to the United States Patent and Trademark Office in the US, and then you have to do the same in each individual country, or sort of a representative office for a group of countries, for example, the European Union. And you have to argue your case, or we argue your case on your behalf, to get a patent to allowance or issuance. So in order to obtain a patent, the invention has to be useful. So that's one of the more simple requirements, because obviously most of the inventions that we would want to submit would be useful. The invention must be novel, it must be non-obvious, and it has to meet the written description or enablement requirement. So the novelty, we have to make sure that the invention that we're applying for a patent is different from other solutions that already exist. So we actually do what's called a prior art search. We look for references and related patents or any type of information out there. We have proprietary databases that we use to look for that information. And we look to see whether or not somebody else basically published the solution as you are proposing it, or maybe you published your solution, maybe as an abstract before going to a meeting, for example. That happens occasionally, or a manuscript. So that's also pretty straightforward. The non-obvious requirement, non-obviousness, is a bit more challenging. The question ultimately is, is it non-obvious over what already exists in the area to someone who is skilled in the art? And the reality is that, this is sometimes difficult to argue with USPTO because sometimes hindsight is 20/20. When you have a solution in hand and you look back, it seems obvious, except that it took 20 years to get there, and a lot of funding and a lot of research efforts by a great number of scientists. So that's where, a very skilled patent attorney comes in handy. That's why they charge a lot of money, because the arguments that they put forward to argue that the invention is not obvious are really important and key in our ability to successfully get the patent to issue. So to that end, we work with 12 outside law firms that have a great spectrum of expertise because we have a lot of different technologies that we pursue, and we rely on them to draft patent applications when we decide to move forward, to help us argue in front of the USPTO, to communicate with foreign patent offices through their colleagues in other countries. Okay, moving on to the disclosure enablement requirement. Basically, Dan, the description has to be, we have to describe the invention and the method of practicing the invention in the patent application in sufficient detail that when the patent term, which is 20 years, is up, anybody can follow what we wrote in the patent application, similarly to a recipe in a cookbook, and practice the invention. Okay, next slide now. So there's patentable subject matter and non-patentable subject matter. So the patentable subject matter includes composition of matter, methods or processes or machines, and improvements of any of the above. Non-patentable subject matter includes natural physical phenomena, abstract ideas, or inventions solely used in nuclear weapons, or actually, I guess, illegal use. Next. And just a fun fact for you to ponder, the correlation between patentability and commercial value of an invention is none. So an invention might be patentable, but have no commercial utility. And that's what we look at when we consider whether or not to move forward with a particular invention. We consider patentability, we consider commercialization potential, and we consider stage of development. Next slide. So some of the main hurdles that we deal with in patenting has to do with prior art. So prior art, we talked about the novelty and obviousness, and prior art includes evidence that your invention is already known or may be obvious. And these are the examples of prior art. Publications, paper or online, presentations, including posters, meeting discussions without a confidentiality agreement, theses, patents, sales, or offers for sale. So what this means is that, this is all possibly a bit complicated. And our strong recommendation is when you feel that you have an interesting idea or potentially an invention, or you create something that you think others may be interested in, that you reach out to one of us so that we can together develop a strategy, and as Mehdi said, become your best friend, on how to move it forward. It may be that, your stage of development is not quite there, it's just an idea. That's okay. We'll talk to you about what might be helpful to develop that idea forward, who might be able to help you with moving that idea forward. We may even have some gap funding. We have commercialization focused funding, to move the technology along the development timeline, pipeline, etc. So with that, I think I'm turning it over to Dan. Is that right?
Andrea.
Andrea, okay. Thank you, everyone.
So, good morning, everyone. So it's my job to introduce to you what I would call as non-traditional intellectual property, which really means other types of intellectual property that are typically not the same as something you would patent. Just a little background. I joined the Innovation Ventures team in 2017. I have a background in intellectual property, but most of my career was spent working in the enterprise software area, and I've done almost every job you can do in the area of software development. Also, I have a bachelor's and a master's degree in computer science, and I got my master's degree here at Rutgers. So, non-traditional intellectual property, we'll start with copyright. Copyright includes software, and it's probably the biggest thing all of us who are taking part on this in this meeting or webinar are familiar with. So copyright covers the expression of the idea, the expression and not the idea. So you might have a new way of doing a sort, and copyright covers the code. That's how you express it, not the actual idea, not the new way of sorting. You might be able to patent the new way of sorting depending on what the novelty is. So, but the code is protectable, it is valuable, and it's commercializable, meaning you could potentially license it, you could potentially start a company around it. The rights, the set of rights associated with the copyright are the rights to distribute, the rights to copy it. You can either give a person or an entity permission to copy or not to copy, to display, to perform, and to modify. So giving someone permission to take your code and modify it, change it, add to it. You can give them the right to do it. You can tell them they don't have a right. You can tell them they have the right, but they can't distribute it. So these are the sets of rights you might have in the work of authorship, the copyrighted work. Interestingly, copyright is automatic. When you create the work and it is stored in a tangible medium of expression, for example, written down, typed in, draw something, you have a copyright. You don't have to file anything. You have the copyright. In fact, you don't need to use the copyright symbol. You don't need to register. And you're not even required to use statements like the ones I have on this slide that indicate that something is copyrighted with the year and who you are. But it helps, and you should do it. And if you ever come to talk to me about one of your copyrighted works, I'm going to tell you to use the statement, the second statement that talks about the copyright, the date, and the fact that it's reserved for Rutgers University. You may be interested to know that we rarely actually register copyrights, but we have copyrighted works that we manage and license and that have been disclosed to us. It's just not required. So I think that's it for this slide. Okay, examples of different types of creative works. And these are the kind of works that we are typically working with here at the university. Again, you can see that there are things that are expressed or written down like curriculum and educational materials. We have videos. Most of these types of works have value to people outside of the university. They might have value for free. They might have value for money. They might be things like on the creative work side that can be turned into actual software or products or digitized in some way. I think I've already said we do license a lot of software, and just as examples of kinds of products that have been licensed that are copyrighted works that never were patented. When companies like Facebook and Dropbox started, they didn't have patents. They do now, but they didn't when they started. You don't have to have a patent in order to have something that is licensable, that is of value to others, that is commercializable. A benefit of copyrighted works are that you have the copyright almost immediately. Once you have an algorithm created, or once you've created some kind of curriculum, it's done, it's available. You don't have to spend a couple of years going to the patent office and filing and prosecuting the patent with the patent office. You have it almost immediately. Immediately sometimes can take a few years. There might be a work that needs to be done if it's software, but it's very quick. Okay, next slide. Trademarks, I think Tanya mentioned that we do have obtained some trademarks for some of our invention, some of our researchers and some of our research. A trademark is usually associated with a business. It's a brand. So you see we have the Google and the Apple marks here. They're used in commerce. They identify a source of goods or services. When it's a service, it could be you would usually call it a service mark. It can be also logos or pictures, but there's something that represents a known, it becomes affiliated with the business. And in fact, so much so that marks that originated like for Xerox are not trademarkable anymore because they became almost associated with every device of that type. So when I go to print something on our Ricoh printer, I might tell someone I'm going to Xerox something. The marks at the bottom are the Rutgers marks. We actually have an organization within Rutgers that when you want to use the mark, if you're an outside entity and you want to use the mark, you have to go and get permission because they have so much value to Rutgers. They want to make sure that they're used properly. On the right bottom, you'll see some marks that we obtained for some of our own researchers. One's for something called risk train modeling. I think Dan's going to talk about that. And another is a specific training program from one of our neuroscientists. The marks last forever. They get renewed every 10 years. And just like with copyright, you don't have to use a symbol. Your mark does not need to be registered. If it is, you can use the R with the circle. But if you have something that you want to have as a trademark, you can start to establish kind of your right in the trademark by using the trademark symbol that we have on the top. Okay, next slide. So Tanya mentioned trade secrets. When you think of a trade secret, or when I think of a trade secret, I always think of Coca-Cola. Coca-Cola, there's no patent for the recipe for Coca-Cola. It's a secret formula. They don't want anyone to know. I'm certain that they make their employees sign non-disclosure agreements that they provide that information. Since it's never gotten out, and in this world we know everything gets out, it must be kept highly secret. Few individuals know. There's employment agreements, and I think they've done a really good job. Another one that's well known is Kentucky Fried Chicken. They have a special formula for, I think, not only the recipe, but how it's made and when things are made. I think trade secrets would be great to use with software, because software can be very difficult to patent, but it's difficult because that means you can't tell anyone what your software does. You can't make the actual code available to anyone, and you have to probably make it hard to reverse engineer. And in a university setting, you can't let anybody know about it. So I think it's extremely difficult. But it's a great way to protect recipes, formulas, ways of making things, and other business information. It's just very difficult. It's not only difficult for us in the university setting, but I think it's even difficult in business. You have to have a lot of processes set up to make sure that the actual trade secret is kept secret and that you can prove that. Okay, next slide. So I think Tanya mentioned this a little bit, but there's a process for commercializing, and in particular, our organization has a process that we use when it comes to commercializing our the various kinds of intellectual property. At this point, I'm talking about patents. I'm talking about all forms of intellectual property, patents, copyrighted works, trademarks, anything that would be disclosed to our organization. So the disclosure process is very simple. In fact, this whole process for the faculty, researchers, students who come to us is meant to be as easy as possible for the person disclosing. You've already done the hard work by having something that you want to disclose to us, whether it's something that's patented through your research or it's some materials that you've created. So we have right now on our website, we've got forms for disclosing inventions, software, works of authorship, or materials to us. And I'll just say that within the next year, we're going to be making that process available online. So you disclose to us, and the next step in the process is that we perform an assessment. So we investigate many of the things that already Tanya talked about. We're going to look at patentability. Is this patentable? Is it useful? Is it novel? Is it non-obvious? Can it be made? We're going to use some of the tools she mentioned to see, are there other papers out there? Are there other patents out there that are similar? How similar are they? We're going to look at the commercial utility. Is there a market for it? Are people going to want this? From a technical standpoint, is it realistic? What are the costs involved? We're going to come up with an assessment that we actually present internally to our team to do a go, no-go decision. If it's no-go, it might be that maybe there's some additional work that we think needs to happen. Maybe there's some additional funding that's needed. We offer two potential ways of funding from our, we call it gap funding. Dan's going to talk about it, called Tech Advance and Health Advance. Maybe there's a little bit of money that will help mature the technology so that it's a little further along the path towards commercialization. And we have other people who support people who are interested in startups, and Rubric is an organization that provides has some labs and equipment that can be used to help further the technology. But after the assessment, we're going to talk internally and determine what's the next step. And in general, a lot of our research, the next step is going to be whether we file a patent application or not. And again, right now, from the standpoint of the person disclosing, the amount of work that's been involved hasn't been a lot because it's been the licensing manager who's been performing a lot of these steps. The next step, if we decide to file a patent application, is we engage one of our 12 law firms. and we work with them to file a patent application. The disclosure is involved in that they review the application, but they're not heavily involved in the process, except as is necessary or makes sense. So once we filed the patent application, now it could be that this is a form of intellectual property that does not require patenting, like software or some curriculum, in which case the assessment is still done, a patentability assessment isn't done, but a commercial assessment is done, a marketing assessment is done, and the patenting step is skipped, but the marketing and assessment step happens next. That step is looking for parties who may be interested in using the technology. It could be that we're talking or looking for large companies, or it could be that the marketing is going to be in assistance with someone who's interested in a startup. So the next step is to negotiate a license. Again, it can be with an existing company or startup, or it could be that it involves further research and someone provides some funding because they're interested in the technology but want to take it to the next step. And then there's a chance that the license would happen subsequent to that. And finally, once we found a commercial partner, we have a part of our organization that is out there following up on, that's performing compliance activities. They're following up by making sure milestones are met, by collecting fees. There's work that happens to make sure that the people we have licensed our technology are actually making good use of the technology and succeeding in getting it out into industry as there's been a commitment to do through the license agreement. Dan?
All right, my turn. I'm going to try to go relatively quickly so we leave a few minutes at the end for Q&A. Very quickly, my background is undergraduate electrical engineering, MBA, and 25 years in industry, primarily in telecommunications and software technologies, in bringing new technologies and new ideas to market. I've both done a number of startups as well as working in kind of the largest companies looking at those startups. We thought it would be useful to give just a few examples of some successes that Rutgers has had in licensing technologies. And then I'll talk a little bit about the startup support. So here's an example, SciCut, where Dr. Nosker invented a new way of using recycled materials in various kind of railroad construction materials, right? Ties, and I don't even know what some of these things are, sleepers and mats and I-beams. All these things, instead of being made out of virgin steel or wood, are made out of recycled plastics. It was licensed in 2006. They expanded the territory to worldwide in 2016. We got a license issue fee, we got maintenance fees, we're getting royalties, and Rutgers got a piece of equity in the company. And remember what Tanya said earlier, 25 to 35% of all of these revenues that come into Rutgers end up going back to, in this case, Dr. Nosker and any of his collaborators, end up going back to the inventors. So there's some real opportunity here for the inventor to make some money off of their ingenuity. Some other examples of Rutgers innovations, Dr. Lalonde and his partner, whose name I'm not going to try to pronounce now, licensed a point-of-care diagnostic machine for TB that was licensed to Cepheid, and it's now spread out all over the world and generating revenues for Rutgers. And Rutgers is also actually pretty famous for its cranberries, and a lot of actually a lot of cranberries, but some other agriculture as well. Here was a cranberry that was patented, actually the second cranberry in history in the United States to be patented. It's ocean spray. We all hear about. You'll go to the store, you find ocean spray cranberry juice. It's actually being made from cranberries that were developed here at Rutgers. An example of software, right? So everything we talked about before the examples were patents. This is a software package that was developed in the School of Criminal Justice risk terrain modeling that use data to kind of best predict where resources should be placed, right? Where crime is likely to happen and where resources should be placed. It was developed with grant-funded research. So as per the policy, it was owned by Rutgers. Rutgers got a trademark, and we ended up licensing it to a startup that is out there after having some, it was developed in-house. It was used in-house for a while. There's some consulting engagements using it, and it's now being developed and being put out into the market as a full software product. No patents involved in any way. We also have a facility called Express Licensing, where we are able to take works that are complete, and we're able to put it out onto the web for people in the public to download, either for free or for pay. So there's a credit card payment facility available with the appropriate license involved. So we can, and there are various different kinds of licenses. It can be full commercial licenses. You can do anything you want with it. We have a lot of materials that are put up there for research only, meaning that other researchers can use it, but if a commercial company wants to use it for profit, they need to come and talk to us and pay us for it. So if you have a kind of a piece of software that you think you'd want to make available to people in general under various different types of arrangements, come and talk to us. We'll also help you if you want to do open source. We can talk to you about what open source licenses are appropriate depending on what you want to achieve. Andrea talked about the various different rights and different open source kind of gives different amounts of rights and lets you maintain different levels of control. So we don't have time to go into all of that today, but if you're interested, if that's a question, come and talk to us about it. I'll spend a couple of minutes talking about new ventures. So we do have a new ventures and commercialization funding team that you see here. And the idea here is, it's hard, right? There's a gap between what you have in the marketplace, in the lab, and what a marketplace needs. And whether that's your own company or licensing to an existing company, we want to help you along the way to maximize chances of success of doing that. And that's, if you think about it, right, there's a number of various different phases of this experience, right? Starting from on the left from education, you have to you guys are researchers, right? You know a whole hell of a lot about the science, which I much of it I don't understand, but about the business end is something that you guys haven't had in your training, understandably so. So we provide a number of educational resources. We have at Rutgers an iCourse site, which I happen to be on the teaching team of, that goes through customer discovery process. And the idea there is there's no better way to know what your customers want and what they need than going and talking to them and finding out. And the iCourse process is about exactly that. It's a 5-week course. We expect you and a team to have 25 interviews over those 5 weeks. And I'll tell you, people, it's going to be transformational for researchers to kind of get out of the lab and into the outside world, and you find fascinating new things that you never thought about. We also have some innovation and commercialization boot camps, and I'll talk about Tech Advance in a moment and Health Advance. Those are actually prerequisites to applying for a Tech Advance or Health Advance. So once you kind of learn a little bit about kind of what that journey is going to look like, there's oftentimes a technology gap between where your technology is coming out of the lab, kind of a lab prototype, and what a company or a VC investor is going to want to see and is going to be wanting to take a risk on. And that's what Tech Advance and Health Advance are for. Health Advance is related to anything that is involving human health. So it's not just life sciences. If you have an algorithm to look at sonograms or MRIs and detect something, or we have a technology that helps in disinfection and sterilization. Those are all involving human health and can qualify for health advance. There's also Tech Advance, which is a program for any technology, provides up to $50,000. Health Advance is up to $200,000. That's in partnership with the NIH, Health Advance, to take your technology and move it forward to a more commercializable stage. So it can be prototypes, it can be data collection if that's what's necessary, a variety of different things. One of the prerequisites for Tech Advance is actually we have to go out and talk to industry and get industry input to find out what it is that industry would want to see. Right. So if we're going to put $50,000 into a technology, what would they want to see to make it more attractive to them? We also have relationships with some outside entities, two that are highlighted here: the Jersey Health Foundation and QED out of Philadelphia, that provide grants, not only grants but also mentorship and kind of technical support. Technical is in the form of business help and mentors in industry to help move that along. Now, again, going down across the spectrum, once you have an idea and you're talking to your customers and you have some sort of a prototype, you need a business team. Like I said before, you guys are scientists, you're researchers, right? You may not want to leave the university, maybe you do, but you need people who know about how to run a business and how to get things started. And so there's a process to help pair you with business founders. I won't go into the details. EIR, the Entrepreneur in Residence, is an internal program. Academic Venture Exchange is an external program that where various different universities have pooled resources and pooled mentors. And then once you have that team, you need money. And we have, again, this team helps with how do you get funding, dilutive funding, which is giving equity, non-dilutive funding, which is grants, SBIR, STTR. We actually have a Genesis fund where there's some non-dilutive grant funding available for committed teams that need a little bit of a kickstart to get going. We have relationships with VCs and a number of other investment groups. So this kind of goes, we try to support through the full spectrum of getting that business off the ground. An example of a successful startup in the last year, First Responder Technologies. It's based out of Win Labs, a technology from Dr. Yiying Chen, to find dangerous materials in baggage using Wi-Fi signals and artificial intelligence looking at the dispersion of Wi-Fi signals. We licensed it in June 2019. They actually did an IPO 6 months later. In January, raised almost $4 million. They've actually are in the midst of raising a little bit more money. The products are expected to come out early next year. Rutgers received licensing fees, royalties, and importantly, further sponsored research. So more dollars came into Dr. Chen's lab to continue doing this work. I'm running out of time, so I won't spend too much time talking about all of these various startups. The point really here is, right, if you're thinking about a startup, right, this could be you, right? And we encourage you, if you have an idea, to come and talk to us and see how we can help you. And with that, I think I will open it up to questions. I see one question in the chat. How do you find prior patents of the same idea? Is there a way to search quickly? So patent searching is it's as much of an art as a science. Google has patents.google.com. I don't know if you guys are familiar with that. So you can search patents using keywords there. There are also various resources provided by the U.S. Patent Office. And one resource that actually I would really encourage you to take advantage of is Connie Wu at the Rutgers Library. She's actually funded by the Patent Office to support education around exactly that, around patent searching. And Mehdi, she may be somebody you might want to invite for the series. She gives a wonderful seminar about how to search for patents, and I won't even begin to do justice to it. But she has a whole methodology and goes through all of the resources. If you don't have time for that, I can actually check to see if we have a recorded version of that we can share.
No, that's a great idea.
But she really does a fantastic job of explaining how that process works and what to do.
You know, we actually invited her for the colloquium a few years back, but the talk was more on the academic side of using the resources Rutgers offers. But that would be very interesting for this series also.
I just want to give a quick plug to the event that we are hosting. We're actually going to have the director of USPTO virtually visit Rutgers on December 1st at 3 p.m. So be on the lookout for that announcement. It should be coming by the end of this week. And the discussion will be on the future of American innovation and diversity, inclusion, ways to involve everyone in the innovation and entrepreneurship community, a discussion around what issues exist around that and how the USPTO and universities can help address all of those issues. We're all very excited about that. There's going to be a panel discussion as well with representatives from the Rutgers community, postdoc students, and faculty. So please be on the lookout for that and join us on December 1st.
That sounds very exciting. Yeah, if you could maybe forward it to us so we can announce that for our students, that would be great. So actually, one question that I wanted to ask is, could you guys clarify what is the definition of an inventor on a patent? Is it, for example, if there's like a paper that comes out of the invention, a publication, conference, or journal, is everybody that's on the paper also, should they also by default be on the patent, or no, is it more?
So that's an excellent question. The inventorship determination is a legal determination, and an inventor is somebody who has contributed to the conception of the invention. So it's not the pair of hands that maybe did the work as instructed, and it's not a co-author, for example, who helped write a paper. I don't know, the discussion section, but it could be one suggestion that makes its way into the claims around the claimed invention, and then that person would be a co-inventor. If there's ever a question, then we work closely with outside patent counsel, because as I said, it's a legal determination. And the way that we do it is we have a list of claims in a patent. So if you look at a patent or an application, there's the abstract, there's the sort of the background. The anatomy is kind of similar to a manuscript, but the most important part that it has is the claims at the end. I claim the invention, and then you sort of number one, and then there's a statement about that, number two, and you could have independent claims and then dependent claims. So we have a listing of the claims, we circulate it to the people, and we say, how exactly did you contribute to claim one? How did you contribute to claim two? And then based on that, together with outside counsel, we make a determination of whether or not that person is a co-inventor.
Thank you for clarifying that. So another question that comes to mind, and I think maybe a lot of people might be thinking this is, how does publishing in a conference or a journal, or giving an invited talk at another university, or maybe even talking to somebody at a private company about your idea or invention, a disclosure, right? How does that affect what rights you have, and where, and at what point should people come to your office to disclose their inventions and file something?
Sure. So we talked about novelty and non-obviousness. So that disclosure that you just talked about, is something that would affect the novelty requirement. So in the US, there's a 12-month window. If you publish an abstract, you have 12 months to file a patent application, but you forfeit foreign rights. So you will not be able to protect or pursue a patent for that invention in a foreign country. And if it's anything like a CAT scan, that will be obviously a problem, because any company that you will want to invest in developing that to the stage of a commercial product will not invest significant resources in something that they're not going to have exclusivity on in foreign jurisdictions. So, so that really speaks to the need to come to us early, just to sort of discuss things in general. And the one thing that I really want to stress is when people submit an invention disclosure to us, sometimes they consider that as a tedious process. We have to fill out all this information. I think Andrea mentioned that we're putting in place an online inventor portal, which is an online form that hopefully will streamline the process of submitting an invention. And the reason why we ask all that information is because we need to look at that prior art to determine the novelty and the non-obviousness. And then we store it as a record. So that was disclosed to us as an invention, and then it's date stamped. And then it's, it sort of memorializes the fact that you were the first one to come up with this idea. And then if it ultimately turns out that we're not quite ready to file a patent application because we're not going to be able to meet that written description requirement because we don't have enough data, we don't have enough sort of proof that it works. And what we really don't want people is to be discouraged when we say that we're not going to move forward with something, because we're not going to move forward with something at this time, or for the reasons that we will share with you. We feel that it's going to be difficult to enter the marketplace because it's a Me Too product. When we say that it's not quite ready because of the lack of data or supporting documentation, what we're really hoping is that you'll be able to, go back to the lab and do more. We want to move forward with as many inventions as possible for a great variety of reasons. We're excited about this. This is what our mission is all about. So my point is, if you come to us and it turns out that you came to us too early, hopefully you will receive some education in the process. We don't want you to be discouraged by us saying no, because it's not no indefinitely. It's not, it's a no for now and for what we have in hand. And hopefully you will have learned something that will get all of us to a yes, let's go next time.
Thank you. So another question is, can students also submit, like undergrads or graduate students, or can only faculty submit invention disclosures?
So another good question, all great questions, I'm loving it. So I talked about the fact that we disclaim ownership in student. It really, for the most part, affects undergraduate students, because graduate students are usually paid through a grant or sponsored research. So it really speaks mainly to the undergraduate students. We disclaim ownership in intellectual property invented by most cases undergraduate students without significant university resources, yada yada. So that means that they're the inventor and they own that invention. And if they disclose it to us, that's public disclosure. So they can disclose it to us, but we would need to sign a confidentiality agreement. So what we've done in the past is a student would informally reach out to us, because I mentioned that we want to be a resource. We're here to help. An undergraduate student would reach out to us and say, hey, I have this idea. I don't quite know what to do with it. Don't know if it's worthwhile. Can you help me get to the next step? And we will do that, initial look into and the initial conversation. Again, I want to be a resource, for us to be a resource to the community. we'll just sign a confidentiality agreement so that it doesn't create the issue of novelty in the event, that the student moves forward with patenting on their own. And that's it. So I wouldn't, if the student believes that the invention belongs to them solely, I would reach out to us verbally first and ask for a confidentiality agreement. If there's a question, we can discuss more generally without disclosing the details of the invention. So there are ways to do that.
Sounds good. And also, if a student, for example, like a graduate student is working with their advisor, and both the advisor and the students involved are inventors, the student can initiate, they have to get permission from everybody and include all of the inventors' names, but the student can also initiate the submission, right?
Yes, absolutely. I mean, we hope that everybody's getting along and sort of communicating with one another, because that's really going to make for a successful effort all around. But yeah, anybody can initiate that.
Okay.
And just one last point about the inventorship. It's actually, a requirement that inventorship on a patent be correct. So a patent that doesn't have correct inventors listed, maybe too many or too few, is not an enforceable patent. So inventorship is actually something that is one of the first things that gets litigated in a patent around a successful product. So we take that very seriously, and whenever there is an issue or a concern, we spend a lot of time up front figuring that out.
Thank you so much. So I guess we are just at 11 o'clock right now. So I think this was a super informative session. Thank you so much, Tanya, Dan, and Andrea, for your time and for all of the great information you gave, and all of the support that you provide to inventors here at Rutgers, and helping them with their innovations, protecting the IP, and also helping find avenues for the IP to benefit society. So you're a very valuable research source, and I hope the students and faculty in our department here at this talk also realize that. So thanks again for your time, and if there are no other questions, we can conclude the event.
Thanks again for having us. And if you can share the secret of getting so many people on, that would be terrific.
Sure. Sounds good. Okay. Thanks again. So have a great day.
Thank you. Thank you very much, Mehdi. And we'll make sure to get you the invitation, the information about the December 1st session.
Thank you. Thank you. Yeah, we'll send that out for our department.
Thank you, both of you. Appreciate the opportunity.
Thank you. Thanks again for your time. Have a great day.
Take care.
Take care. Bye-bye.